Welcome to Unit 9, Weak Acids and Bases. This is Lesson 1, Video 1. We are going to talk about relative strengths of acids in this first lesson. So there are 4 different ways that we can look at relative strengths, and that means that we're comparing acid strength to one another, not necessarily if something is a strong acid and a weak acid, but in a comparison of acid strength between a given set of compounds. So the first thing that we're going to look at is the polarity of the bond between the hydrogen and whatever it's attached to, whatever other element. So we are looking at periods on the periodic table here. So those are the horizontal rows. So basically, when we're looking at polarity, if you know that fluorine is the most electronegative substance, then that is going to help you with a lot of these different things. So the greater the difference in polarity, and that's going to be between H and what it's bonded to, the stronger the acid. So if you remember, polarity deals with how electrons are shared. So the greater the difference, the more pull something has. So acid strength is based on how easily that H is pulled off of something, how it ionizes. So if the thing that it's bonded to, the X, has a stronger pull, the easier it is to break off this H. So we're just going to say it's easier to pull the H from the compound. So if we look at an example here, it says list the following compounds from strongest acid behavior to weakest. So strongest would be 1, weakest would be 4. And we look at these are all have H's in it, and they're all bonded to another element. All those other elements are in the same period of the periodic table. So if we know that that fluorine has the highest electronegativity, and then it decreases as we go away from there, that also is going to be our trend here. So this will be our number 1, because fluorine has the highest electronegativity. So we're looking at the greatest difference in electronegativity or polarity. And then as we go across, oxygen would be number 2, nitrogen would be number 3, and CH4 is number 4. We also can look at the size of the anion in the HX bond. So this is what we use when we look at groups in a periodic table. So we're looking at the columns. So as the X, which is the other element, gets bigger in size, the bond between H and X gets weaker, which means that we have a stronger acid. That's because as the H gets further and further away from the nucleus, it's easier to pick off the H. It's not attracted to the electrons that are surrounding that nucleus. So it gets further and further away from that electron cloud. As X gets bigger, those electrons are spread out further in the electron cloud in the outermost layers. And if we get bigger, those electrons are even further out. So it's easier to pluck off that H or have it be removed. So things that are higher, like fluorine, oxygen, anything in those top slots are going to be a weaker acid. As we go down, they get stronger. So if we look, here we have H with Cl, I, F, and Br. These are the halogens. They're all in the same group. So the further down it is, the stronger it is. So the furthest one down is Hi. Then Br, Cl, and F. And if we look at these, HCl, Hi, and HBr are all labeled as strong acids. HF is the only one labeled as a weak acid. So comparatively, it's the weakest of all four of them.